This is Mr. Coolis. This is the first half of chapter 3.4, solving log and exponential growth and decay equations. What I would like you to do is make sure you have your notes out. You can have this document. It's online and downloadable. And grab your calculator. You're going to need one of these. Have it out, have it on. And I would like you to start by pressing pause in this video and see how many of these equations that you can do. When you unpause it, I'll give you the answers. Okay, so our answers for this set of problems are those, and I'm going to just give you a quick rundown on how to get them. So we ask ourselves in this problem right here, this first problem, 7 to what power is 49? 7 squared is 49, so we get 2. 3 to what power, this isn't even a log or a pigtail equation, 3 to what power is 243? So you just multiply 3 times 3 times 3, you just keep doing it until you get 243. It takes 5 threes to get 243. 1/2 to some power is 32. I notice it has to flip. So that's the negative exponent, and 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so it's negative 5. 1/4 to what power is 64? It didn't flip, so I didn't make the negative. Cubed. ln of x equals 3. E to the third is your answer. I did write a note at the top. We're going to give the ACT version of each one of these answers. The way I would have done this is I would have changed ln to log base e of x equals 3, and I would have pigtailed it. E to the third equals x. Here's one from the 3.3 condense expand material. So minus can be rewritten as log base e. I'm going to change ln to log base e, but then minus can be written as division. X over 2 equals 4. So I condensed it, writing that as division, and I changed ln to log base e. Now I can pigtail it. E to the fourth equals x over 2, and I can multiply both sides by 2 and get 2 e to the fourth. Again, I'm going to condense, make it log base 10. Log with no base is log base 10. Plus means times, so 2x equals 2. I'll pigtail it. 10 to the second equals 2x, and that's 100 divided by 2, which is 50. This guy right here becomes an exponent. That was another rule, and I'll pigtail it. 2 to the sixth equals x to the third. 2 to the sixth equals x to the third. Well, an interesting way I could write this, I have a sixth power here and a third power there. I guess maybe the best way to do it would just be to multiply it out. 2 to the sixth, 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4. Got 3 sets of 4, so that's 64. So x cubed is 64, and I can cube root it and get 4. This one is a one-to-one property, or the wap-wap property. Log base 3 and log base 3 go away, x equals 4. And then the last one, ln is the same as log base e of x equals negative 7, and I can pigtail it. E to the negative 7th equals x. Okay, these were pretty simplistic equations, and by simplistic I mean, well, you could do them with either in your head or a minimal amount of work. What this chapter is really about is more complicated log equations. How do I solve when I have x's in the exponent and it's not easily just seen or whapped out, discovered, any of those things. It's something that we have to do some type of algebraic process on. And that's what this is really about. That's what the whole chapter is about, solving for x when x is an exponent. The cool part is there's no new properties at all. We don't have to do anything new. I don't have any new condense, expand, anything. No new pigtail. You have everything that you need in your tool belt. You just have to be able to use them. So let's use the ones we have. And I'm also going to show you how to make sure you're right either on Desmos or on a graphing utility. So make sure you have those out also. So part one here, we are going to be able to solve these exponential equations. So what you want to do is you want to be able to take the equation and you want to be able to boil it down to its innermost piece. And what I mean by that, I got these numbers up here, but this 2 to the x is what I want to boil it down to. So I need to remove everything that is not with 2 to the x. I want to remove everything that's not with e to the x. And removing it is just an algebraic process. So I'm going to divide by 3, divide by 3. And I get 2 to the x equals 42 over 3. And you could decimalize that. I'm just going to leave it. Okay, 42 over 3. And at this point, we boiled it down to its innermost thing. So now I'm going to, and there's really 2 trains of thought. One train of thought is you could pigtail it. So you could go log base 2 of 42 equals x. Or you can think about it as using a log base 2 on both sides. I added it on the left side and I added it on the right side. And the reason this way works is because log base 2 of 2 is 1. That whaps out and I'm left with x equals log base 2 of 42 over 3. That's the algebraic, that's the ACT answer. No decimal right there. So again, back up to this step really quick. I want to make sure you understand this. Right here, I could pigtail it. Log base 2 of 42 equals x. That would skip this step and get me right down to here. Or I could think about it as tacking a log base 2 on both sides. Right here is what I did that, and then these 2 wipe out and I'm left with x. It really doesn't matter which way you think about it, they're both correct. Regardless, I need to evaluate that as a decimal. So I'm gonna go to my math button. Here's where you should take out your calculator. You're gonna need a calculator of some type for this test. If you don't have one, find one. So I'm gonna go I'm gonna go to my math folder. I'm gonna hit my log base button and I'm gonna go log base 2 of 42 divided by 3. And what I got out of that is I got an x value of 3.807. Basically, that's it. I got my x value. Now, for each one of these, there's also a graphic check. Okay? I'm going to show you what that looks like on the calculator. What you want to do is you want to take the left side, and you're going to enter the left side into y1. I get 3 times 2 to the x. Should be a growth graph that got stretched 3. I'm going to have a growth graph, and that 3 in front is going to stretch it up. And the y2, I'm going to put 42. And I'm going to graph both of those in y1 and y2. So clear. In y1, I got 3 times 2 to the x, and you should be entering these on your graphing calculator. It should not be a deal where just I'm doing it. You should also be doing it. And in y2, I put 42. So I got 3 times 2 to the x in one of them, and I got 42 in the other one. And I'm gonna hit my graph button. And I did get the growth graph stretched, but the 42 is not gonna show up because y equals 42 is way up here. It's like this line that chugs across up top. So I'm gonna zoom out and I'm gonna see if I can go find that. There's my first zoom out. There's the growth, and I still can't see it. So I'm gonna zoom out one more time. And when I zoom out a second time, I bet it pops up. I bet I'm out far enough. Nope, maybe not. Oh, there it is. So there's my line. So the red line is y equals 42. The blue is the growth equation. So I have this thing that goes like this. That's that one. And then I have this other graph that chugs across like this. That's that one. And there's a little point where they hit at. That point right there is this answer. And you can check it every single time you do one of these. So what I can do here is I can go up to it. I put my little dotty little cursor on this, and this is pretty easy on decimals. You can just go and get there if you had it on decimals. But here I am in my graphing calculator, so now I'm gonna zoom in. There's once. And I'm gonna see if I can go find that point. So it does take a little bit on these calculators to do that. I'm gonna zoom in one more time. You should be going through this process also. And I'm going in to find that little spot where they hit. There's gonna be a line. They hit right there. And I'm gonna put my cursor right on top of that little intersection point. And I notice that intersection point is 3.86 41.7. Oops, and if I zoomed in, I get some ordered pair like 3.8, 41.82 is what? Well, that's the ordered pair, 3.807, and then 42. So it looks like the x value of that graph, where they hit at, is the answer for my log equation. So here's what we got. We got ACT version of the answer. We got decimalized version of the answer. We have a graphical check to make sure we were correct. Let's keep going. That's pretty awesome. All right, e to the x plus 5 equals 60 is the next one. First thing I'm going to do, I'm going to move the 5 over. So I'll go minus 5, minus 5. I get e to the x equals 60 minus 5 is 55. Okay? Now, again, I could pigtail it. I can go log base e of 55 equals x. Log base e of 55 equals x. Or I could think about this. What cancels e's out? Well, ln's get rid of e's. So I'm going to tack an ln on this side, and I'm going to tack an ln on this side. I get ln of e wipes out, and I get my x value is equal to the ln of 55. ACT answer. X equals, graphic answer, well, decimal answer first, the ln of 55. The ln of 55 is 4.0073 something. Decimalized answer, ACT answer, decimalized answer, graphic check. E to the x plus 5, e to the x is growth that shifted up 5 units. So this is a exponential growth graph that shifted up 5, 1, 2, 3, 4, 5. So, and then the dot went from 0, 1 to 0, 6 with the asymptote at 5. So here's my picture. And then I got this graph here that chugs along at 60. So here I'm going to graph the 60 part. I'm going to put y1 is 60. Well, I know what that looks like, so there's 5, 10. I would have to go way up here, and I would have to chug that graph across, and there's this little point that they hit. Well, the x value of that point right here, the x value of that point should be 4.007. So in y1, I would type in that, and well, I've already put y1 in 60. So in y2, I'll tack in e to the x plus 5. I'll tack that in my graphing calculator, I'll put that in my graphing calculator, and I'm gonna go find that point where they hit. Okay? I want you to press pause now. It's a skill to be able to go do this. I want you to press pause. I want you to enter them into your graphing utility. And I want you to go find that point. I want to see if we're right. You should really never ever miss an exponential growth and decay problem solving for x, because you can always plug it in your graphing calculator and you can always go find that point. Press pause now and do that. Okay, last couple here. We have a little bit harder one to solve algebraically. So again, I have to boil it down to its innermost workings. That's this part right here. So I'm going to add the 4 over. I got 2 parentheses, 3 to the 2t minus 5 equals 15. I'm going to divide by the 2, and I got 3 to the 2t minus 5 equals, well, 15 over 2. I could write that as 7.5. I'm going to leave it 15 over 2. And it's pigtail time. Log base 3 of 15 over 2 equals 2t minus 5. Or tack on log base 3 onto both sides. And log base 3 of 3 is 1. 2t minus 5 will drop down out of the exponent. I have 2t minus 5 equals log base 3 of 15 over 2. I'll move the 5, I'll divide by 2. 2t equals log base 3 of 15 halves. Plus 5 to the other side. And divide by 2, divide by 2. I will get my t value, that is log base 3 of 15 halves plus 5, or 7. You know what? Nope, I can't combine those two because this is This is log base 3. I almost added those two together. I can't do that. So log base 3 of 15 halves, in parentheses, plus 5 all over 2. Weird ACT version of it, but it would look something like that. Maybe they put a 7.5 there. Regardless, I'm going to go find out that answer. Math, log base 3. I'm going to go ahead and put 7.5 in there. Close off the parentheses, plus 5. And then I'm going to divide it by 2. I got 3.4. ACT version, decimalized version, plug this into Y1, plug this into Y2, see if we're right. You do that right now. Last problem, e to the 2x plus 2 equals 0. E to the 2x plus 2 equals 0. So again, we're going to boil it down to its innermost workings, which is e to the 2x, and then I'm going to apply that log thing. So I'm going to go minus 2, minus 2. I got e to the 2x equals negative 2. I'm going to ln this side. I'm going to ln this side. ln wipes out e. I'm left with 2x. When that goes away, equals the ln of negative 2. And then I'll divide by 2. I'll divide by 2, and I get my x value equals the ln of negative 2 over 2. Pretty easy. Not too bad, but it's kind of quirky, so stick with it. Plug in the ln of negative 2 over 2 right now in your graphing calculator and see what you get. Because it turns out that the ln of negative 2, well, I can't have a negative sign in that spot. This is undefined. This is undefined right here, this ln of negative 2. So I'm going to write that x is no solution. And why did I write no solution rather than undefined? Well, what we're trying to figure out is where does e to the 2x plus 2 hit the line y equals 0? Because when I think about this side as being y1 and this side as being y2, I'm going to perform a graphical check. E to the 2x, e to the x is growth. The 2 is probably going to stretch it up a little bit. So if I was going to dot it in, I'd have a growth graph that may be stretched up a little bit. And then plus 2 would take the whole graph and it would shift it up 2. So if I do this side, let's do this side in blue here. So y1 is e to the 2x plus 2. It would be, let's back that off a little bit here. I want to look at a little bit better picture of it here. There we go. So I'm going to do a little bit better picture. We had to dot it in. We know it's e to growth, but then it shifted up 2. So this graph is going to look something like this. And it's got an asymptote right here, so it's not going to keep going down. And then I'm going to do this side, y2. I'm going to do that side in red. Well, y2 equals 0. That would be this line right here. And you know, from a graphical check aspect, we're asking ourselves, well, where do those two meet? Well, this line doesn't go past that asymptote. This line is here. They never meet. So there's no solution. There's no time. There's no x value that I can plug in there and get out 0. So I wrote no solution, not undefined, even though this was undefined, because in this original equation, there's no value that would work. I think that's the end of part 1. In part 2, we will start talking about solving some log equations. That'll be the second half. Hopefully you took good notes and you're ready to go for that half. Good job.